Good day, everyone. We're back once again. I am James Andrew V. Palacio, and together with me is Mr. Ryan Hojas. Today, we will be discussing understanding measurements. So, what is a measurement? According to this, a measurement is something that involves determining the size, length, quantity, or extent of something with standard units, aiding in understanding and quantifying the characteristics of objects or phenomena. Essentially, it entails figuring out the dimensions or amount of something using a recognized scale or unit in comparison. Why is measurement important? It is important because it enables us to understand and compare quantities, communicate effectively, and solve problems by quantifying characteristics using a standard unit, facilitating clearer comprehension and decision making in various aspects of life. Here is our overview for our lesson for today. Here we will be learning the concepts of length, area, volume, mass, temperature, and time. This will all be discussed by Mr. Ryan Hojas. Let's make way for him.
So now let us start of one of the types of measurement, which is the length. So length is all about how long something is, or how far apart two things are. We use different units to measure length, like meters, centimeters, inches, feet, and yards. If we're measuring something bigger, like a room, we use some meters or even kilometers. Here you will learn that the basic unit for measuring length is meter. So it's like a universal ruler that helps us measure things accurately in a way that everyone understands. So for example, if we try to measure our pinky fingers to our other fingers, so we know its length. So the fitting measurement that we use will be the centimeters. So in this figure, with this man, so 1 meter is equivalent if he fully set apart his both hands or arms. So that would be equivalent to 1 meters. So what about 1 kilometers? So 1 kilometers is much has a longer distances compared to meter. So to clearly or to more elaborate what 1 kilometers, 1 kilometer, there are 100, 1,000 there are 1,000 meter in 1 kilometer. So let's say for example you're going to join a fun run under category of 4K. So that would be 1 kilometer. So with the conversion, remember in conversion 1 millimeter or the abbreviation of it, mm, as well as centimeters, cm. So 1 millimeter is equivalent to 0.1 centimeters, and 1 meter is equivalent to 100 centimeters, and 1 kilometer is equivalent to 1,000 meters. So that would be length. And now let's proceed to the area, which is the another type of measurement. So area is the space inside a flat shape, such as a rectangle or a circle. It's how much surface the shape covers. So how do we solve each different shape? So let's start with square, where its formula is A equals L times width. So our length would be in the left upper corner, 2 cm, and our width with at the low 2 cm, at the low bottom 2 cm. So 2 cm times 2 cm is equal to 4 centimeters squared. So do not forget to times cm is equals centimeters squared. So let's start with a rectangle. Same formula where length times width. So our length 2 cm and our width is 4 cm. So 2 cm times 4 cm is equal to 8 centimeters squared. So let's proceed to the triangles. Now if you wonder why is it A equals 1/2 L times width. So I'll further explain that with this rectangle, with this green rectangle in the left corner, where it has already found the area of, or it is already fixed, and its area is 12 meters squared. So now, why is it 1/2 of the formula of triangle? Now, we split the rectangle shape, and it formed two triangles, and in its area is 6 meters squared each. So it formed two triangles. So uh that is why the formula of triangle is 1/2. So it should be 1/2. So instead 1/2 L times width, it should be 1/2 B times H, which means base times height. So we will use this formula or try this method using finding the area of acute triangle. So here we have the base where 3 meter, and its height it is 8 meter. So 3 times 8, 24. And here the 1/2 will be used. 1/2 of 24 is 12. So the area of the acute triangle is 12. So let's proceed to another type of measurement, which is the volume. Measured in cubic units, volume is the amount of three-dimensional space that is either occupied by matter or surrounded by surface. The derived unit of volume used in International System of Units, or SI, measurements is the cubic meter. So how do we solve or find volume of any shapes? So let us start with the rectangle prism. Where to find the volume of rectangle prism, let's start find the area. Where so the area would be the base of 4 centimeter, and its height is 3 cm centimeter. So what we will do is to times them. So 3 times 4 is equal to 12. So 3 centimeters times 4 centimeters is equal to 12 centimeters squared. So here we have the area. So let's proceed to the length. So the length would be 10 centimeter. So here's the length, 10 centimeter. So what we'll do next is to times 12 centimeter squared times 10 centimeter. So 12 centimeter squared times 10 centimeter is equal to 120 cubic meter. So our volume is 120 cubic meter of the rectangle prism. So what about triangle prism? So first let's find the area where 10 inches and the height 8 inches. So 10 inches times 8 inches is equals to 80 inches squared. So what we will do next is to 1/2 of 80 inches squared is 40 inches squared. So we just kind of divide it with a 1/2. So it becomes 40 inches squared. So what about the length? So the length is 30 inches. So we already find the length. So 40 inches squared times 30 inches is equal to 1,200 cubic. So we have 1,200 inches cubed. So let's proceed to cylinder. Where to find the area of cylinder? Where pi times radius squared. So to find the radius of this circle, or its base of the cylinder, is 2 meters. And if we squared it, it becomes 4 meters squared. and will times by pi, which approximately 3.14 or 3.14. So 3.14 times 4 meter 4 meters squared will become 12.56 meters squared. Sorry, I forgot the squared meter. The squared. So here we find the area. So the length would be 10 meter. So 12.6 meter squared times 10 meter is equal to 125.66 cubic meter. So therefore, our volume is 125.6 meter cubic meter. And now let's proceed with the mass, which is another type of measurement. So mass is defined as the matter that is present in the given object. Following are the most commonly used units for the of for the measurement of mass: gram, kilogram, milligram, decigram, centigram, gram, decagram, hectogram, metric ton, and kilogram. So milligram with a 0.01 gram or 1 to 1000 gram, or decigram is 0.1 to 10 gram, and centigram 0.01 gram or 1 over 100 gram, and gram 1000 milligrams, decagram 10 grams, hectogram 100 grams, metric ton 1000 kilograms, kilogram 1000 grams. In this, for example, the price of each bag of rice is often determined based on its mass. For example, a large bag containing 5 kilograms of rice may be priced higher than a smaller bag containing 2 kilograms, even if they are of the same brand and quality. And now we are at the temperature. Temperature is a measure of hotness or coldness that can be stated on any number of arbitrary scales. It also shows which way heat energy will naturally flow, that is, from a higher temperature body to a colder, lower temperature body. It measures our body, environment, objects. We measure the temperature in degrees Celsius or degree Fahrenheit. So there are two types of thermometer: Celsius thermometer, Fahrenheit thermometer. So how do we convert Celsius into Fahrenheit? To convert Celsius to Fahrenheit, we'll be using the same C to F formula. Fahrenheit equals to Celsius times 9 over 5 plus 32, where C measure of temperature in degrees Celsius centigrade, F measures of temperature in degree Fahrenheit. To convert degrees Celsius to Fahrenheit, we can follow the steps given below. Step 1. Identify the temperature value in Celsius. Multiply the given temperature by 9. Step 2. Step 3. Divide the product by 9. Step 4. Add 32 to the result of step 3. That will be the required value in degree Fahrenheit. For example, let's convert 20 Celsius to Fahrenheit. Fahrenheit equals 20. 20 times 9 equals 180. 180 divided by 5 equals 36. And 36 plus 32 is 68 Fahrenheit, or 68 Fahrenheit. Therefore, 20 Celsius is equal to 68 Fahrenheit. So that is temperature. And now we're at the last type of measurement, which is the concept of time. So let's start with a second. Second is the smallest or the shortest amount of time, where you could count the seconds of blinking of your eyes, and seconds in the clock is the second or the second longest line. And minute on a clock, minute is shown with with the longest line, and its abbreviation is min, and 1 minute is equal to 60 seconds. And with the hour, hour is something that you can do, for example, in a morning in your yard, or even watching a movie is equivalent to 1 hour. So here we have days, such as 15 days, 30 days, 40 days. And we have week, third week of December, November, October, and months, such as April, May, June, July. And we have years. Years is something like a duration from 1996 to 1999 would be a good example. And century. Century is something like a longest amount of time where it could span up to 50 to 100 years. So this is the concept of time.
Thank you for your explanation, Mr. Ryan. Next, we will be discussing the metric and imperial system units of measurement and its conversion. First, let us begin with the length. Length is a measure of how long or short something is. It's fundamental for understanding the size and dimensions of objects. In the metric system, we use units like millimeters, centimeters, meters, and kilometers. For example, millimeters are great for measuring tiny things like the width of a pencil tip, while kilometers are used for vast distances like the length of a marathon. In the imperial system, we have units such as inches, feet, yards, and miles, each serving a different purpose from measuring the height of a person in feet to calculating the distance between cities and miles. Next is area. Area measures the extent of a surface in two dimensions and is crucial for understanding spatial dimensions. In the metric system, its units are square meters, square centimeter, and square kilometer, are used for varying scales of surfaces. Conversely, the imperial system employs units such as square inch, and square foot, tailored for specific applications. Mastery of area measurement is pivotal for fields such as construction, architecture, and urban planning, facilitating accurate assessment of spatial capacity. The third would be the volume. Volume is a fundamental measure of space for three-dimensional objects. It is pivotal for comprehending their size and capacity, especially in relation to liquids, gases, and various shapes. In both metric and imperial systems, different units are employed to measure volume based on the object scale. In the metric system, the cubic meter is utilized for large volumes, while the liter and milliliter are preferred for smaller quantities. Conversely, the imperial system relies on units like cubic inch, fluid ounce, and gallon, accommodating a broad spectrum of volumes ranging from small objects to larger containers and liquids. The next would be mass. Mass is a fundamental property of matter that represents the amount of substance in an object. It's essential for understanding the quantity of matter present in an object and plays a crucial role in various scientific everyday contexts. In the metric system, we use units like grams, kilograms, and metric tons, while the imperial system, units such as ounces, pounds, and tons are commonly employed. Next would be temperature. Temperature indicates how hot or cold something is. In everyday life, we often use Celsius and Fahrenheit. Water freezes at 0 degrees Celsius and boils at 100 degrees Celsius. on the Celsius scale, making it convenient for scientific and global use. Meanwhile, in the Fahrenheit scale, water freezes at 32 degrees Fahrenheit and boils at 212 degrees Fahrenheit. Additionally, there's the Kelvin scale, or K, primarily used in scientific contexts. It starts from absolute zero, the lowest possible temperature, making it ideal for calculations involving gases and absolute temperature measurements. The last one would be time. Time measures the duration of events or intervals between occurrences. We use units like seconds, minutes, hours, and days. Seconds are precise, like counting heartbeats or the duration of a blink. Minutes are handy for short durations, like cooking times or phone calls. Hours are for everyday use, like work shifts or movie lengths. Days are for longer periods, like the time it takes for Earth to complete one rotation. In the imperial system, the units are the same but may have a slightly different conversion. Next, let us proceed into the conversion of units. Unit conversion is the process of converting measurements from one unit to another while maintaining the same quantity. It is a fundamental skill in mathematics and science, allowing for flexible expression of measurements across various units. Understanding unit conversion is crucial for accurate analysis and communication of measurements in diverse contexts. Here is a step by step guide to unit conversion. The first is to identify given measurement. The second is to determine conversion factor. The third is to set up a conversion equation. Number four is to perform the calculation. Number five, and the last is to check units and round up if necessary. In the first step, we will start by identifying the given measurement and its current units. For instance, if a given length of 2 meters. First, we must find the conversion factor related to the given units to the desired units. For example, to convert meters to centimeters, the conversion factor is 100, or 1 meter is equal to 100 centimeters. The next is to write the conversion equation, placing the given measurement with its units on one side and the desired units with their conversion factor on the other side. For example, 2 meters times 100 centimeter over meters is equal to question mark centimeters. We then multiply the given measurement by the conversion factor to find the equivalent measurement in the desired units. In this case, 2 meters times 100 is equal to 200 centimeters. Lastly, we must ensure that the final result has the correct units and round up to the appropriate precision if needed. Here are more examples to this. Here is another example. In converting kilometers to meters, we have a given of 5 kilometers. Then we must convert it to meters. The conversion factor of kilometers to meters is 1000. Next, we'll multiply the number of kilometers by 1000. In calculating, we multiply 5 kilometers times 1000 meters over kilometer. It is equal to 5000 meters. Result, 5 kilometers is equal to 5000 meters. Example number 2, we must convert liters to milliliters. We have a given of 3 liters. Liters to milliliters is how we must convert it. The conversion factor is 1 liter is equal to 1000 milliliters. The method is to multiply the number by 1000. In calculating, 3 liters multiplied by 1000 milliliters over liters, it is equal to 3000 milliliters. The result, 3 liters is equal to 3000 milliliters. Next, we have the third and last example. In here, we must convert square feet to square meters. We have a given of 10 square feet, and we must convert it to square meters. The conversion factor is 1 square feet is equal to 0.0929 square meters. The method is to multiply the number of square feet by 0.0929. In calculating this, we must multiply 10 square feet times 0.0929 square meters over square feet. Then we will get our answer, which is 0.929 meters squared. The result, 10 feet is equal to The result, we will have 10 square feet is equal to 0.929 square meters. Thank you for watching, everyone. Please access your assessment via link in this video's description. Bye.